Okay, hello everyone. Welcome to this week's distribution demo. We are 1 minute past the time. I'm just going to give it a few more seconds in case someone else wants to join. This week's demo is about debugging GitLab operator. I want to show two different scenarios. One, debugging against the env test, which is a test environment, and the second one is debugging GitLab operator while it is running against a fully functional cluster. So the second one is actually more helpful. The first one is helpful for development purposes, but the second one is more useful for finding the issues that's happening with the deployment of GitLab operator and reconciling the resources. So you just try to deploy a new I'm trying to deploy a new operator with the Helm chart, but the problem is that since I deployed it with the previous chart and deleted the chart, there are some of the resources that are still sitting, but we can get back to it later. This is actually one of the problems that we have with the chart, because it leaves some of the resources behind. The cluster resources, not the namespace scope resources. So I think we're good to go. So the first scenario is, let's see if I can make this bigger, more visible. So I'm going to use VS Code, but basically you can use Delph if you are using another editor. The commands are the same. I just find it easier and more quicker to work with, especially when I'm developing the operator. So to begin with, I'm gonna start a test environment, and I'm going to debug one of the test cases that we have for controllers. This is the main test that we have here. So just a quick overview of the env test, which is a test environment for testing operator. This is part of the GitLab operator framework. Sorry, this is part of the controller runtime framework that we use. And what it basically does, it starts an etcd and a kube API server, wires them together, and offers them as an API server to the operator that we are developing, to the controller that we are developing. And we can do very few basic tests with the env test with this API server. But the problem is that since it doesn't have a control plane and it's just only a test API, can do only API testing, nothing further. And if we want to add more details, we need to imitate what the control plane does. That's why our tests are a bit slow and difficult to expand and catch corner cases. But right now, I'm just going to start one of these test cases and bring it up into debug mode, and then we can check it. So the code that I am reviewing right now, this is the setup of the env test. You can refer to the documentation, but basically what we do, we are collecting the CRDs and configure the environment and just start it. And then when it starts here, it actually brings up the processes outside the etcd and kube API server, outside the main process of the controller itself. In this case, it's test process. So I am going to just this looks like something that we can test here. I'm just going to put a breakpoint here. So I have a test case defined for this one. Let me show you what this one looks like in terms of the configuration for the operator, VS Code configuration. So you just need to start your process in test mode, and the program that we are testing is a suite test of that particular package. So these are the important parts you need to consider. The program, this is the main program that we are testing, and this is the Helm chart, the environment variable that I am passing, and you can also pass the Ginkgo command line arguments. Actually, I'm going to just remove this because I don't want to test this control now. So I'm going to start my test. I should be able to grab this. So let me bring up the debug console. This is the delve command line. I can start passing commands to delve. So let me see if I can show you if the API server is coming up. Oh, sorry. So we have the breakpoint. Here it is. The Cube API server is started. This is what env test has started and passed all the parameters. You can also check for etcd. The background etcd is running as well, and the API server is wired to this one. And what this does, it creates a temp file, a temp directory, and it contains all the information that the API server requires. So let's take a look at this directory. One of the interesting things that is here is the kube config file. So if I do this, and do kubectl get namespace. We're actually clustering there. This is the cluster that is running on the Cube API server. So now I'm going to play with the test case, and then we can, with this, we can grab the resources that are created or anything that is happening inside the test environment. So let's say, okay, this is a debug environment. You can, of course, do what you want with the values. You can inspect them. You can watch them. You can create a conditional. This is a fully fledged debug environment. Nothing much to it. The only caveat here is that you cannot do a lot of nested structures, basically any structures, the map string interface or map of interfaces. You cannot dig too much into it. I think a few levels, yeah, Delve doesn't like it. It requires a bit of configuration of Delve and adding some, changing some buffers. For example, some of the strings are cut short. These are the parameters that you can configure with Delve. And basically, if you are using VS Code, you can configure it via VS Code to pass it to Delve, so you can get more, you can read more of the buffers or strings, or getting more nested structure of the structured databases, nested data structures. But for the purpose of this demo, we're not gonna we're just gonna stick to the defaults. It's enough. So I am going to. So the GitLab resource should be there. Yeah, and we can. Sorry. Just keep going. So this is a resource that is created. We can keep doing this and go on. Let me just grab something else. Actually, shared secret is not bad. It's a good example. Let me just move on to the next. So the controller is running. Still no. Okay. These are the config maps for the that are created by the controller. If you want to check them, look how it will really end up in the Kubernetes API. This is the way that you do it. Just write it, just copy and paste it. Here it is. Useful for debugging the templates, debugging the object structure. But again, this is just the test cases that you can use. I find myself doing it from time to time. That's why I actually have, I think I have two functions for, yeah, I have two functions that strips the, I'm just going to share it with as a debug snippet in the development documentation. These are useful. This one, the first one actually, the first one finds the temp directory of the API server that is running. The second one just grabs tries to find to locate the kube config, and I find myself just, you know, do this. Try to connect to the local API server that is running on this env test and try to fiddle with these things. Sometimes I can even change these things and to make sure that, you know, the operator. Actually, if you see that the operator is still creating these things as it goes ahead. So this is one of the things that is helpful, but not the most interesting thing that you can do. So just let's start the debug. If you have any questions so far, I can answer it. If not, we can move on to the second part of the demo, which is debugging the operator against a live cluster. So I think there's no question. Don't worry, I'm just gonna, if you didn't grab these things, I'm gonna just create an issue and add it as a development documentation to the operator. So, as I said, that this is limited. This doesn't have a control plane, and we just basically testing the development environment. But from time to time, we find that we need to actually have a control plane and find out what is happening. I can give you an example. A few releases ago, we had a problem with HPAs, and we really didn't understand what is happening with HPAs. Anything that we were setting was changing, the number of replicas, and we had to bring up the cluster into a debug, bring up the operator into debug mode against a real cluster and find out what is happening, because we needed those minute detailed information. So what you need to do at this point, let me show you what we're going to do. This is a new operator that I created for this is a new operator that I created with from 0.11.3. It is running. There is no GitLab resource yet. And I want to debug my operator against this cluster. This is a GCP cluster. Can do it. That doesn't matter. Can do it with everything that you want. So to begin with, now we need to debug the main program, the actual GitLab operator. So first things first, the operator, when it is deployed, it has two parts. The first part is a service that serves the webhook, validating and mutating webhooks. This is the thing that when you throw the GitLab resource into the cluster, is called by the API machinery via which is configured via validating webhook and mutating webhook, and is connected, talks to the controller as a service, and tries to validate or change, update the default values of the resource. So this is the part that does the request and response. After this step, there is another part to operator which subscribes to watches certain resources. In this case, or for GitLab operator, it watches the GitLab resource. So if a GitLab resource is created or changed or deleted, it will be notified and it will pick it up. This is kind of like a pulling rather than pushing. So it can be from the operator side. If you look at it from the operator side, it pulls the changes from the cluster. For the first part, we cannot really debug it on our local machine because we need to have a valid pod sitting behind the service and serving the validating webhook and mutating webhook. So to begin with, if you want to create a resource, what you need to do is to make sure that the operator is running on that cluster. And let me show you this. So this is the resource. Let me see if I can find any example right here. Config. Yeah. So let's take this sample. I'm just gonna, this is 11.3, so I think we have 6.3.3. Doesn't matter that we have this. Let me add another. This is here. Okay. So when we do this, it will create the resource. This is a bit of a tricky part because as soon as we add the resource, we need to pause or delete the operator because we want this not to be reconciled with the operator that is deployed, but the operator that we are running our local machine. So I'm just going to bring up the deploy. I have a script for this. I don't do this manually generally because this needs to be quick. But for the purpose of demo, I'm just going to do that. Okay, and now I'm going to delete the operator. So there is no operator on the cluster to reconcile this. Let's take a look at the resources. We have the resource here, which is created. And okay, I was wrong. This is, I should have added another one. But that's okay. It doesn't change anything. I just created that one. So let's go ahead and play with it. So there is no operator on the server side. We have an operator. So first of all, make sure that you are debugging the same operator that you are running. So I am going to check out the V01130. This is the same code that we are running on server side. And I'm going to debug the reconcile function here. Right here. For the debug, this is the beginning of reconcile function. Remember that the resource is on the server side. Now, this is the first step. The second step is that if I run this into debug mode, it fails. Let's take a look. Okay. The reason that this one can connect to the remote cluster is that we already have a kubectl that can work with the cluster. So it can still pull the resources. It can watch the resources. And the fact that we are importing all the authentication modules, including GCP in operator. So we can authenticate to GCP or any other provider. So with the kubectl, we can connect with a valid kubectl on our local machine, on our environment variable. We can connect our GitLab operator to a remote cluster and it works. The problem that it doesn't work here is that I think we kind of need to copy the certificates because there is a certificate. And we cannot really detect these things. So we need to grab these certificates and add it to a temp directory. Because when operator starts, it tries to locate these certificates. And let me just see if I can do that. So it looks at a very specific directory. Serving systems. So let me get the certificate, get the secrets. So this is the okay. This is the TLS key. This is TLS CRT. And this is CA cert. Let's see if I can start this now. Okay, yeah, we have. So this is running against the cluster. The resource is in the cluster, but I can debug it from here. So I'm not debugging remotely. The thing is, the whole test fixture is remote. It is a real cluster rather than an existing cluster, or test like an ELF test. So you can go ahead and get the resources. This is the resource that I have. You can see that I can debug, inspect. And ultimately, it has to fail because no, it didn't. Oh, I think I know what the problem is. I didn't check out the right branch, I guess, because the template is there. I messed it up. The charts directory already contains 633, despite the fact that, so my test and my local environment wasn't exactly the same as the remote environment. It shouldn't have been here. I should have updated the charts to reflect the exact same version that is running on the cluster. But actually, this is not bad because I can go ahead and try this thing. Let's say I want to see if resources is enabled. Let's say, yeah, let's say like we want to reconcile, check debug reconcile to this, and just let it go. And let's take a look at pods. It has started creating everything. The resources are running. This is a real cluster, and reconcile loop is running as well. And I can just say waiting for a breakpoint to reach, and I can tap into it and just see what happened. That's it. That's basically it. Oh, this is the second reconcile loop. Just going to remove this one. The catch here is that you cannot really modify the values. If you want to change the values of GitLab resource, automatically it needs another service to respond to that. You can check that by, I'm just going to hold the and let's say we are going to go and change this version to let me see if I can. No, actually, I was able to change. So the problem, the caveat is that you need the controller running in the cluster to create the resource in the first place. And after that, it is okay to change it. But the important thing is that you need to make sure that either that deployment is stopped or deleted. Otherwise, you will end up with two controllers, which starts forming looking for leader, starting building a quorum, and then you may end up with two reconcile loops, and you can be sure that which one actually picks up the request that you have brought in. Part of this is scripted, and you can reuse it, but part of it is actually requires a bit of jumping through a few hoops to make sure that you get the result that you wanted. But this is a very effective way of debugging the operator because it is transparent and you get all the information that you need, and you can see how the operator is actually working with a specific configuration. So the next time that you are trying to investigate an odd issue, this is probably the way to go. So this was a short demo. We finished it on the dot. If there is any question.
I think the only question I have, and it's just clarification, we don't strip the Go binary of symbols or anything, so we can just take any of the generated binaries and run them in a debugger, right?
For the release we do, because this one is actually compiled in debug mode, it has the debug symbols. So if we take a look at here, there should be, sorry, this is the debug bin. Yep. There is a debug version of the binary here, but this is not, it doesn't have to be published because we compiled it locally. Right. We just used a feature that actually leveraged a feature that the controller runtime has, and that's pulling the changes. So as long as we can authenticate to a cluster with kubectl, we can run an operator locally against it.
Right. Yeah, that makes sense. Okay. No, I couldn't remember if we stripped our binaries or not. And like you say, it makes sense we do it for release.
Yeah. By default we do. By default we do, unless you actually instruct the compiler that I need the debug information. But this one is actually compiled in debug mode.
Okay. Is that true with like if I build a binary from our pipeline, it leaves it with the symbols in, and only during the release phase that we actually strip them?
No, there is no. To the best of my knowledge, there is no debug symbol in the binary that we release. So the binary that we will end up.
No. I'm saying if I run a pipeline, if I'm working on a change and I run a pipeline, I can take the binary off of that pipeline because it hasn't gone through the release stage yet. It's just been built. That would have the symbols in it.
No, that one is also stripped.
It is. Okay.
Yeah.
Okay.
You cannot really grab that binary. You cannot really grab that binary. You kind of need to do that locally if you want to debug information.
Okay. Yeah. Might be something we want to think about. It's just for our normal pipelines, branch pipelines, leave the symbols on and only strip it when we actually produce a release. It does make it bigger. It makes it more storage. I understand, but it's
that's all right. I mean, we do not keep that one. That one is not kept forever. I think we have a policy. I need to double check. We can have a policy to remove the artifacts after a while.
Yeah, exactly. Either that or.
But there is a problem.
Make an artifact of the non-stripped binary. That, if it stays for a week, fine. I can grab it well within a week and work with it. If it's beyond a week, purge it.
Yeah, but there's a problem with that. That binary is AMD 64 Linux, so we cannot really run it on your Mac.
Well, that's true. Yeah, I wouldn't necessarily be running it on my Mac, but maybe I would. I don't know. But yeah.
But probably the easiest way to get the debuggable binary is to just compile it in your local machine. It doesn't really take that long.
Yeah, true. I was gonna say I could be running on Linux and just talking to it over the network to debug it.
Yeah, probably you find it easier to compile it locally. It's fairly straightforward. The Go compiler is not like GCC. It is as long as you have the dependencies. If your Go mode passes, then you can compile.
True. Okay. Just thoughts at this point.
Yeah. Thanks. Any other question? I think I have to just create a follow-up for this and start adding some of these to the developer documentation. So it would be easier for everyone to just use it and leverage it.
Do you have to worry about timeouts or probes kicking off or things like that while you're debugging it?
When you are debugging with env test, you should, because the env test, that's the structure of the that's the way that we wrote the test cases. For controller runtime, okay. General rule of thumb, if you are debugging the test cases with env test, you should, because just let me show you this. Because of this. If you look at this line of code, it uses a promise. It eventually has to converge to a condition. So we use ginkgo, and there is a timeout here. So when you are testing your env test, your local API server, you need to get it done within that poll timeout, which I think is fairly It is 30 seconds. You can increase that if you're debugging. But for the cluster itself, no, you don't have that kind of timeout, especially because of the recent change that we made, that instead of waiting, blocking the wait, we just postpone and come back to it. That basically we requeue the request. If you do not finish what you are debugging in this cycle of reconcile loop, you will end up doing it in the next. So we basically requeue instead of waiting with a specific timeout. Yeah. For the live cluster, no, you don't have to be worried a lot about. Depends on the case, but in most cases you don't have to be worried about it. But with AFTest, it is sometimes a good idea to just tweak this whole timeout and increase it, so you can go ahead and make a change in your local cluster, local resource, and see how the controller reacts.
Okay.
Okay. Thanks everyone for joining, and I hope this was a useful demo, and catch with you all later. Thanks. Have a good day. Bye-bye.
Have a good day, Hussein. Have fun.
Thanks.
Thanks, Hussein.
Thank you. Bye.
Thank you.